Good afternoon, everyone, and thank you so much for joining our webinar today. This is the earthquake webinar that will be talking about how to prepare for earthquakes before they happen and what to do when an earthquake happens. On your screen, you'll see instructions for a tool we will be using today called VVox. We'll get to that in just a minute, and as we get started, we have a few housekeeping things for you today. There is a Q&A box that you may see in the upper right corner. If you don't see it, go ahead and click the icon that looks like the Q&A messaging icon. Click on that and you can post a question or a comment at any time. Our presenters will be answering questions at the end of this webinar, so feel free throughout the entire presentation to add any questions or comments. If you'd like captions, you can turn those on by the settings icon in the lower right corner of your screen. Few other housekeeping things is that we are using VVox, as I mentioned. This is an audience engagement tool that allows us to interact with you. That way we aren't just talking to ourselves. We'd like to hear from you. We'd like you to be involved in this discussion today. So it's very easy, very simple to join. In a web browser, on a tablet, or on your phone, simply type in the website address, vvox.app, just like it's listed there. You don't need to add a .com, nothing like that. It's very simple, just like you see it on your screen, vvox.app. When the page loads, it'll ask you for a meeting ID number. That meeting ID number is here on the screen, and if you miss it, don't worry, we'll have it later on in the presentation, so you can join later as well. Once you load the page and you enter the ID number and that page loads, you'll then see this third screenshot that you see on your screen today. It'll just say Earthquake Webinar 2020. You've made it, that is it. So don't worry if you don't see anything else. Throughout the presentations, our presenters will have polling questions. As a polling question opens, the poll will automatically appear on your screen, and then you can choose from the answers provided. Of course, you are not getting a grade for this. This is simply just to interact with our presenters. So this can be a discussion about how to build preparedness throughout Washington. With that, don't forget you can add questions and comments at any time. And with that, I'm going to pass the mic over to one of my coworkers to introduce you to our presenters today.
Good afternoon, everybody. My name is Brian Terbush. I'm the Earthquake and Volcano Program Coordinator at Washington Emergency Management Division. You just heard from Kiana Kavanji, our Hazards and Outreach Program Supervisor. So I'll be talking a little bit soon, but first I wanted to introduce you to someone who's going to tell us a little bit more about what our earthquake hazards are in Washington, because she goes out and actually studies them. So I'd like to introduce, from the Washington Geological Survey, Megan Anderson.
Okay, thank you, Brian. How my slides look? They good? Give me a thumbs up, Brian, if we're ready to go. All right, great. Well, welcome everybody. As Brian said, my name is Megan Anderson from the Washington Geological Survey, and I am an earthquake geoscientist. I study earthquakes in Washington State, and I wanted to kick off this webinar by talking about why earthquakes happen in Washington, what we know about them, and I'm going to focus on some earthquakes that don't necessarily get as much press to bring you some new information. Before we get into earthquakes, though, I want to take a couple big steps back to get us all on the same page about what earthquakes are. Okay, so what is an earthquake? Well, first you need a fault, so we need to talk about faults first. Faulting is a type of deformation or shape change that is caused by breaking rocks. In this slide in the center, you can see a picture of an actual fault. This is on a road cut on the side of the road. You can see that there are layers in the rocks, and the faults are pointed out on that slide. And you can see that the rocks have been shifted and their shape has been changed by the faults cutting through the layers. On the left side, you'll see some more textbook style pictures of a couple different kinds of faults. The top one is a reverse fault. That happens when you have compression or the rocks are being squeezed and one block slides up over the other to allow that whole block of rock to shorten, and that's called a reverse fault. In Washington, we have a lot of reverse faults, and we also have a lot of strike slip faults. Strike slip faults happen when two rocks are trying to slide past one another, and the fault allows the combination of that shearing between the two blocks. A really famous strike slip fault is the San Andreas Fault in California. Now, an earthquake happens when there's an attempt at this deformation or shape change along a fault, but the fault is stuck together and isn't moving. So what you get is an elastic deformation. It's the same kind of deformation that happens. Imagine you're shooting a rubber band at your sibling when you're a kid, and you stretch that rubber band out. You're actually storing some energy in that rubber band, and that is elastic deformation. Well, rocks can do the same thing at a very large scale. But of course, the rocks are only so strong, so eventually the energy will exceed the strength of the rocks. And when that happens, the fault will slide very suddenly, and we create a brittle deformation or breaking, and that's what creates the earthquake. And of course, at that moment, there's a lot of energy that's released that's been stored up in that elastic deformation. So that's what an earthquake is. So to understand earthquakes, we need to talk a lot about faults. So what makes faults in Washington? Well, the theory of plate tectonics suggests that the surface of the Earth is composed of many tectonic plates that can slide around laterally. And in the Washington area, we have two tectonic plates that meet off the coast. And the one underneath the Pacific Ocean is the Huanafuca plate, and the one that we live and work on is the North American plate. And they're moving towards each other, as this map shows. And in that battle, as those two plates are moving towards each other, the Huanafuca plate loses, and it has to go down underneath the North American plate. And the boundary between those two plates is a fault. And so that's where we can get earthquakes. And in this case, on the right is shown what happens with that storing of elastic energy over time. As a subducting plate is trying to go down, the fault is stuck, and so the overriding plate bends and stores up elastic energy. And finally, when the fault becomes unstuck, that plate snaps back and we get an earthquake. Now, you guys have probably heard about this earthquake before. There was a pretty popular story in the New Yorker a couple years ago called The Really Big One. And the image on the left is from that article. The image in the article is just a little bit exaggerated in places. The fault's not really that big, but it's a pretty big fault. The map on the right shows how big this fault is. It goes from all the way from off the coast of Vancouver Island down to Northern California. And I show this because it really emphasizes an important point. That a very long fault can make a very large magnitude earthquake. So it has that potential. And there's this relationship between the length of faults and how large a magnitude earthquake can make. If it's shorter, it can only make a smaller magnitude earthquake. So of course, if this whole fault slid in one big event, that would be a really important and very damaging event for the state of Washington, and it would cause a lot of disruption. But there are other faults that should concern us too in Washington, and I want to bring your attention to those in this 3D image. So as the Huanafuca plate is going down underneath the North American plate, as that plate goes down, it's kind of being bent and moved and deformed, and of course you get earthquakes in that process. And the 2001 Nisqually event is one of those kinds of earthquakes. And I believe Brian's going to talk a little bit about the Nisqually quake during his section and show you some of the effects from that earthquake. I'm going to focus in this presentation on another type of earthquake. As the North American plate is being squeezed by the two plates coming together, it also moves and deforms and creates earthquakes. And those earthquakes happen in a very shallow part of the crust of the Earth. And so they're very close to our communities, and so they're important to study and understand. And so those are the ones that I'm going to be focusing on for most of the rest of this presentation. Now, this image doesn't show much of Eastern Washington, but that doesn't mean we don't have earthquakes there. And so I want to show you a little bit about where the faults are in the state. Now, before we really get into talk about crustal faults in Washington, I want to ask you guys a question. So hopefully we can pull up the VBox. All right, so my question for you guys is, where are you from in Washington? Are you from the Puget Lowland? Are you from the Olympic Peninsula? Are you from Southwest Washington? Maybe you're from the eastern part of the state in the Spokane area. You might be from the Yakima and Ellensburg area, just on the eastern side of the Cascades. Are you from the Tri-Cities or Walla Walla area, kind of that southeastern corner? Or are you from the Chelan area in the north central part of the state? Or maybe you're not from Washington at all, and you let us know that you're not from Washington and yet you're interested in this presentation. So we'll wait for some answers to come in. And I'm curious to know about this because there are many regions in Washington that have a lot of faults, and I wanted to kind of cue people in if they're from a particular area to some of the faults I'm going to be talking about. All right, looks like we're getting some responses. All right. So a lot of you are from the Puget Lowland, and so one fault in particular you may know about, and I'll mention that one later, but I do see quite a few from the Olympic Peninsula and Southwest Washington. That's great because I'm going to talk about a couple of those regions as well. And those of you from the Tri-Cities, Walla Walla area, I'm going to talk about that area as well. And at the end of the presentation, all of those of you who are in Yakima and Ellensburg, Spokane, Chelan, there are places where there are other faults that exist in the state, and we'll of course talk about those. All right. So let's look at a map of faults in Washington. So think about where you're from and take a look at the area you're in. And this slide actually shows all these lines. The blue lines are all the crustal faults that we know about and have studied in Washington state. And for those of you in the Seattle area, you can see there's a lot of faults in the Seattle area. Also the Olympic Peninsula near Port Townsend. Those of you from the Tri-Cities, you'll notice that there are some faults out there too. So different parts of the state have faults. And it may be kind of obvious why we have faults very close to the coast, because what's creating this is the tectonics that's happening offshore, right? So one question you might have is, why are there so many faults out here in Eastern Washington? And to talk about that, I'm going to tell you a little story about how these faults are created besides just subduction. So to do that, I'm going to show you a little data. So we can use high precision GPS to actually track the movement of the Earth's crust, to track tectonic plate movement. It's the same kind of thing that's in your phone that helps track you and on Google and tell you where to go, how to get to the grocery store, but it's a really high precision version, and it's shown in the upper left-hand corner here. We drill a hole in the rock and put in a monument with a big fancy antenna, and we record the position every 15 seconds for about a week. And if we do that, we can get the location of that point to within less than a 1/16 of an inch. And of course, if we do this over a number of different years, we can actually track how that point is moving in space. And in the map in the bottom center is an image showing the movement of a bunch of different points that have been measured across Washington, Oregon, and Idaho. Each arrow is one of these monuments that's similar to the one that's pictured up above. And the arrow shows the direction it's moving. The length of the arrow shows approximately how fast it's moving relative to other places. And so you can see out in Western Washington, the crust and the rocks are moving very fast compared to over in the Spokane area. But something else that's interesting that pops out of this kind of data is you see a big sweep of the arrows turning as they go from Idaho through Oregon and up into Washington, as if there's a big section of the crust that's actually rotating. And that is exactly what scientists think. So there's a place out in Spokane where the crust is just kind of sitting in one place and everything's rotating around it. Now, Canada isn't moving. So this is all kind of with reference to some places up in Canada. So Washington crust is trying to move to the north, but at the border, Canada is stopping us, not allowing us to come into the country. And so there is a clash there. And that happens in western and especially south central Washington. And in the map on the right, you can see that rotation combined with the stoppage at the Canadian border roughly creates a compression or an uplifting in the center part of the state. And that's how we get a lot of the faults that I was showing in the previous map. Here's another view of the faults in Oregon, Washington, and Idaho that shows something interesting about these faults that kind of harkens back to what I was saying in the very first slide, that we have strike slip faults and reverse faults in Washington. And the strike slip faults in this image are shown in yellow and the reverse faults are shown in gray. And you can see that rotation pole up towards Spokane is the blue dot. So what the strike slip faults do is they accommodate kind of a relative sliding of the crust past each other as these blocks of crust are rotating around to the north. And then the reverse faults are kind of perpendicular to the rotation direction and accommodate relative crunching, that crunching of the crust that is caused by Canada not moving. And so you can see we get an array of faults in different orientations, strike slip and reverse, throughout most of the state. Of course, the least action is happening out near Spokane, where everything is moving very slowly. But this leads us to know that we could expect an earthquake to happen pretty much anywhere. It's just more likely in places that are moving faster. Okay, so why focus on crustal faults in the first place for this presentation? Why are they important to us? And it has to do with ground shaking and how the energy that's stored up that creates an earthquake dissipates as you move away from where the earthquake happens. So the shaking comes from wave energy that's created by the fault movement. And that energy dissipates as you move away from the epicenter. So shaking is going to be strongest at the epicenter and less strong furthest away. And a really good analogy is a light in a room, like in the picture in the lower right-hand corner. If you have a light that's on a stage in an auditorium, the front seats in the auditorium are going to be really well lit, while the seats in the back are not. And that's because light energy dissipates as it travels through the room. Similarly, wave energy dissipates as you move away from the epicenter. So that's a good way to think of it. And this is not just a hypothetical. This is something that scientists use, and we actually have quantification. These numbers actually indicate a quantification of the shaking intensity from earthquakes, and we call that the Mercalli scale. And it's a pretty accessible kind of scientific scale because each part of the Mercalli scale describes some earthquake effect that would happen where you were if you felt an earthquake. And most earthquakes are in the light to very strong range. And you can see that what happens is described in each category. So a strong earthquake might be kind of frightening. It'll move heavy furniture. There might be some damage. And we can actually categorize earthquake intensity this way. And Brian in his presentation is going to talk a lot more about these effects. But I'm going to use this scale, these moderate, strong, very strong designators to describe the effects of earthquakes in different parts of our state. And one way in which we do that is by thinking about, well, if we had an earthquake on one of these faults, what would that do? What kind of shaking would that make? And that kind of prediction is called an earthquake scenario. So it's a projection of what might happen. And in particular, it shows the highest potential strength of shaking. It might not be exactly what happens, but it's kind of the highest potential. And that helps us get prepared for the worst, basically. Mainly what goes into this is that fault length, so the magnitude of the earthquake, and then the distance you are from the earthquake. And there's a little bit about the kind of materials that are involved in the shaking, such as the geology of the region, and that produces a predicted shaking in any given region. The map I'm showing here is from the USGS scenario catalog, and it shows the highest potential for shaking from all potential earthquakes that they've modeled in Washington. And you can see that there's a number of different faults that are highlighted. The epicenter is the star, and you can see that even with a smaller magnitude event, you get shaking that's higher, closer to the epicenter, and lower, farther away. But kind of in between those individual faults and their effects, you see there's this vertical striping where near the coast is very strong potential of shaking, and then out near Spokane, it's light. And those stripes are from the earthquake that could happen off the coast, this really big fault that creates really large magnitude earthquakes. So even though the shaking will be heaviest near the coast, people will still see it in Spokane. They'll still feel it. In fact, I was in Argentina in 2010 when there was a magnitude 9.0 off the coast in Chile, size that could be produced by the big fault off the coast of Washington. And I was about as far away from that fault as Western Montana is from the fault we have up here, and I still felt that event. So it was a pretty significant thing. So everybody's going to feel it when this happens. But of course, if you're very close to one of these local crustal faults, you could also get really high shaking due to one of those events. And so I'm going to continue to focus on those as we go forward. So I'm going to focus on 4 key areas, and we're going to start with the Seattle fault. And a lot of you are from the Puget Lowland area, so that's one that you may have heard about. This is one that actually has gotten a little bit more press coverage, and so a lot of you might be familiar with this one. But this is the scenario for the Seattle fault, a magnitude 7.2 earthquake. You can see the area that would rupture here in the scenario, and then the predicted shaking around the Puget Lowland region. The fault runs from Bremerton through West Seattle and underneath the southern part of Lake Washington. So those areas would experience the most shaking. It would be predicted to be violent. So that's a pretty intense shaking. But a lot of places would experience very strong shaking. And this is a possibility, we think, because this fault has been very well studied. Of course, it's under a major urban area, so we've spent a lot of time on it. And a very similar earthquake happened on this fault about 1,000 years ago, and it was about a magnitude 7.2. So this is a kind of earthquake that really do want to be prepared for. Now I'm going to talk about a few faults that you might be less familiar with. There's the Boundary Creek fault, which is on the Olympic Peninsula. So let's actually zoom in on that area. I'm going to show you some topography. So this is a Lidar image of the Sadie Creek fault, which is a part of the larger Lake Creek Boundary Creek fault. And Lidar stands for light detection and ranging. You put this light-based radar onto an airplane and fly it back and forth over the surface and collect a ton of data. And the data kind of looks like in the lower left corner here when you get it, and you do some analysis that allows you to pull out any of the hits where the radar hits trees. And so you can actually come out with a very high precision topographic image of the surface of the Earth. And that's what we see on the right here. And the arrows show the location of the fault. You can see it's a very nice straight line going right across the topography. And so that's how we know this fault is here. I think the best way to see this is the view to the northwest. And one of our publications, people put these images together, which is very great. And this is the view looking towards the west, towards the northwest. And you can see the Sadie Creek Fault Scarp is this line that goes through. Now, this topographic break we call that a scarp. And so what that signifies is that sometime in the past, the fault actually broke the surface of the earth when it moved. And that surface is about as old as the last ice age. So geologically, it's pretty recent. And there's a lot of scientists at the University of Washington who are Western Washington University who are studying this fault. So what would a scenario look like on the Lake Creek Boundary Creek Fault? Well, the rupture is shown here. It's very close to Port Angeles. And so we'd have a magnitude 6.8 that would create very strong to severe shaking in Port Angeles. And something I'd like to point out is that Lidar image I was showing you is in an area that's being studied right now. And it's over actually to the west of where the rupture was modeled in this scenario. And so what the Western Washington scientists are suggesting here with their research is the fault is actually longer than we previously knew. And so it might be capable of a much larger earthquake, maybe closer to a 7. And so clearly further study is needed to really fully understand this fault, but this is what we know so far. Okay, so let's go over to the eastern part of the state and highlight one of those faults. There's a number of faults over there near Yakima, Ellensburg, and Tri-Cities. So let's look at the Wallula Fault. This is the Lidar image of the Wallula Fault. And there's a lot of labels on here. Just ignore those. Just take a look at the topography, and you can see a really well-known topographic feature called the Rattles. That's along the Wallula Fault. And this image really clearly shows the fault as this topographic break that goes from northwest to southeast through the region. And that's one of the ways in which we know it's there and that it's a pretty active fault. So if there was an earthquake along the whole length of the Wallula Fault, that would be a magnitude 7.4 based on what we know. And so we get very strong to violent shaking in the Richland-Kennewick area. But I want to note also that one of the historical earthquakes that's happened in Washington was in 1936 in this region, and there's reason to believe it may have been on the Wallula Fault. It was a magnitude 5.9, which is much smaller than this scenario, but it still created moderate to strong shaking in the Tri-Cities area. And so, you can be prepared for the highest level of shaking. You'll also be prepared for earthquakes that might be a little bit less strong, but also still could, damage your furniture, injure you with things falling and stuff like that. So it's always good to be prepared. Now, you might be thinking throughout this whole presentation, okay, we know maybe what is the worst that we could expect and what to be prepared for, but how often should we expect this to happen? And unfortunately, that's the million-dollar question. I could do a whole nother talk on this question, but the punchline is we're still figuring this out for a lot of these faults. We use an array of different tools to understand how often earthquakes happen on these faults once we identify them. We can use geologic mapping. We can dig trenches, which is what is being shown in this picture. This was work that was happening last year on the Wallula Fault, and they're digging more trenches this summer. And they can use dating techniques on the materials that are exposed in those trenches to understand how often earthquakes happen on these faults. But you can see it's very expensive and time-consuming work to do this on all the faults in Washington, and it's happening. But, it's just happening as we go along. And so scientists are working on it, but we don't know everything about all these faults. We're still learning more every single year. Okay, so I want to go to a part of the state that quite a few people on this presentation are from, Southwest Washington, maybe from Olympia on down south. And you'll notice that I put in here a bunch of question marks in a box. It doesn't appear as if there's any crustal faults in this region. But is that really the case? If you look at the active fault maps that I showed for Washington, there doesn't appear to be any active faults in that region either, but maybe they are there and we just don't know that much about them. So I want to tell you a little bit about the faults near Chehalis and Centralia. So the Washington Geological Survey has been involved in a 3-year project. We're still in the middle of it, trying to better understand faults in this area because we just don't know that much about them. This is a map of faults and folds, which is another kind of deformation in the Centralia and Chehalis area. And I want to point you to especially the Doty fault zone, which is in the center of this topographic image. This is a fault that is very similar to the Seattle fault in size and style. And it goes very close to, goes right across I-5 and very close to Centralia and Chehalis. There's a couple other faults in the region. You can see Scammon Creek Fault, Capaya Fault are labeled. These are larger faults. And we don't really know where these faults go. Usually faults actually connect with each other to break up the crust into blocks that can move around. And you can see that especially the Doty, Scammon Creek, and Capaya faults go and then they stop, but that's kind of a weird thing. All of the mapping that created what we know about these faults was done in the 50s. So we don't really know exactly how long they are either. We don't know if these are the only faults. Maybe there's some that we don't know about, and therefore we don't know how big an earthquake is possible in this area. There's a lot that we need to figure out. And so at the end of our first year of study, we revised this fault map, and I'm going to go to the next slide, and it's a little different in style. So maybe pay attention to one of these faults, maybe the Capaya fault. You can see where it ends here, or the Doty fault, it ends kind of to the west here, and focus on that. And I'm going to switch the slide and see how it changes. All right, so this is what the fault map looks like now. So we've extended the Capaya fault, Scammon Creek fault. The Doty fault does appear to end where it was mapped, but it connects to another fault that wasn't on anybody's map before now. And so we're really figuring out where these faults extend and connect and how long they are. So we've been able to come up with an idea about the Doty fault system that based on its size and length, it could be capable of a magnitude 6.7 to 7.2 earthquake. But we're still engaged in the process of trying to figure out if it's active or not. That's the key question. So doing trenching studies and dating and all those sorts of things, we're still in the middle of that. And so we don't have a scenario yet because we're still even trying to figure out where the fault goes and how long it is in order to do that. But it will be coming in the future. So I want to end on this by just saying, there's a lot of work to do before we fully understand earthquake hazard in Washington. It's if there's any take-home message, it's an evolving part of science, and our knowledge is increasing every year. But wherever you live in Washington, whether there's a fault map there or not, it's good to be prepared for an earthquake. And so I'm just going to show you a couple things and then move into earthquake effects and more of the preparedness part of this talk. So besides, we don't have all the stuff figured out, but we do have some stuff figured out. The fault map I was just showing you is available on our geologic information portal. So if you go to the Washington Geological Survey webpage, the portal is shown on the right-hand side. You click that rainbow flag and you'll get to the map. There's also earthquake information under geologic hazards in the center of the page. And I just wanted to point you to a couple things. If you get into the portal, it looks like this, just like the maps I've been showing, but you can actually zoom in and see a better level of detail. So here's the Tri-Cities area where the Wallula fault comes through, so you can actually see where these faults go through your particular area if you're curious. There's also other kinds of fault hazard information such as liquefaction and ground shaking information that's available from in the portal and also from our earthquakes and faults section. So if you click on the geologic hazard maps, it'll take you to some of those. And then we also have some additional information on faults and earthquakes in the center. And so with that, I'm going to hand it over to Brian to talk more about earthquake effects.
Thank you very much, Megan. Enjoyed your presentation. Megan was able to provide an excellent example of how Washington has its faults. That's one way to put it, but I'm going to talk a little bit more about what that actually means, kind of what that means for your weekend, and what you can actually do about it. Have this slide up with these two guys talking, and you could go around just assuming everything, assuming there's going to be an earthquake at all times, which is kind of reasonable in Washington. You could assume that one's going to be there at any time. However, this isn't something that needs to be on your mind at all times, making you scared. Earthquakes are a scary thing, but I'm going to talk more about how you can be prepared, what's a reasonable amount of preparedness you can put into this. It's more about situational awareness, understanding where you are and what might happen that will help you be prepared and not have to be afraid all the time. So I guess what we're going to kind of do now is I'm going to scare you, and then Kiana's going to prepare you, is what we're saying. So, all right, we're going to start off with this is going to be a VVox poll question. So if you're up there, we're getting some questions about where you can go to answer a VVox question. Now, if you have this on your alternate device, there should be a few tabs up on the top. So these tabs, one of them is going to be the poll, so you should see answers there and a place to answer the question. So we're asking now, what is statistically the safest place to be when an earthquake strikes? Get all sorts of questions for this. Just think about it. It's not a trick question, but some people like to respond, "Oh, up in an airplane." So that's one thing to think about if you're way off the ground, maybe in a blimp or something. But you got to think about landing after that too. So this is really just going to be where have the least of the injuries actually happened in earthquakes. So yeah, if you're unable to find the poll, don't worry. You can still see all the answers and everything. But again, just look for those three kind of tabs up on the top. Yeah, do you think it'd be in a car? What about in an unreinforced masonry building? If you're not sure what that is yet, I'm going to talk about those soon too. It's something we have here in Washington, something to look out for. Getting a bunch of responses coming in, that's good. How about a chemistry lab? Sounds like a good place to shake things up. Maybe outside is good. And again, not a trick question, but you might be surprised by the answer, and we'll hear more about why this is kind of the answer, but why it's kind of conditional as well, based on what we've seen. The way we learn things like this too is from, again, we haven't really had a big earthquake here in a while. We could at any time, but we learn a lot about things like this from looking at other places around the world where there are more earthquakes. Okay, so we've got a bunch of questions. I'm going to close the poll and start to see what those answers look like. All right. Most people are saying outside is the safest place to be. We got in a department store, not very many. That's probably good. I wouldn't want to be in like a Home Depot or something with all those things up on the shelves. In bed, that's a pretty good answer. In a car, some people as well. So why this is not a trick question, but at the same time kind of is, this is very conditional. When you say outside, you could be in a field, but you could be right next to a building. And glass is one of those things that breaks really easily in an earthquake. So a lot of times when you're right outside of a building, you're still outside, but you're still in a lot of danger. So what I'd like to bring up with this is situational awareness about earthquakes and why that's an important part. So statistically, the correct answer is in bed. But again, that's going to be as long as you don't store something sharp or heavy above your bed. So that's going to be something we talk about. But ultimately, I'm glad nobody said in a chemistry lab and nobody said in an unreinforced masonry building. You're doing very well in this case. So we move on. Here's an example of why outside might not be perfect. Now, I do not have a way to ask everybody this, but I assume that at least some people were here in 2001 when we had the Nisqually earthquake. This was a magnitude 6.1, one of those deep intraplate earthquakes Megan was talking about. It affected a huge area of the state. And now this is an example of that unreinforced masonry we were talking about before. So how this works, what kind of building this is all of our buildings and most things on the surface of the earth are designed to stand upright. They're designed to stand up to gravity. That doesn't always work so well when things start shaking side to side, like in an earthquake. That's where you get a lot of the strong shaking. And when they're unreinforced, you can see that the top of the building up here, if we look at it, this wall is not attached to it. It's not bolted into the floors. And you get these top layers above the top floor, above the roof, called parapets. And when it starts shaking side to side, that comes peeling off and can cause a lot of damage in the street. Pretty much when we're talking situational awareness, you would not want to be on one of these sidewalks outside of one of these buildings during an earthquake. And we were very lucky that this happened on a Wednesday in February rather than a sunny Saturday in the middle of the summer, because this Pioneer Square, one of the huge areas that was affected, would have had a lot of tourists out there. So we're very fortunate nobody died in this earthquake, but it doesn't mean that'll happen next time. So we just need people to be aware of what to do during an earthquake. Now, again, that depends where you are. So we created this poster here that you can find at emd.wa.gov/earthquake. And we also have on our EMD Prepare videos on YouTube. The link is in the bottom, but you can check it out. I'm sure it's in there. That's where this video will be posted as well. This is translated into several languages, and it's an animation. So where you are when an earthquake strikes. I mean, I'd like to think I'd know where I am when an earthquake is going to strike, but we can't predict when an earthquake is going to happen. So I mean, you think about the places you spend your most time and try to understand what you would do in that situation, whether you're near a desk or table, what would you do when you're in bed, what would you do at work or at school, or if you use a wheelchair or walker, or we've gotten some questions about tsunamis, what would you do if you're on the shore? So this is a great resource for this. Again, learn from things all over the world, how to protect yourself as best as possible as soon as the ground starts shaking. And you want to take these actions immediately, because right when an earthquake starts, you're not certain of exactly how strong it's going to be. So what can you expect when an earthquake happens? They will strike suddenly, and again, you might get those weaker waves first that happen. Everything will start to shake. You get a little bit of up and down, usually a lot stronger side to side. You might get lights flickering, windows breaking, objects flying off the walls and shelves. So these are things you can fix ahead of time. I was fortunate to be in Alaska, but they had a large earthquake a couple of years ago in November 2018. And I was speaking to a taxi driver there who just started talking about the earthquake, and he was telling me that he was stirring the paint can and then it started stirring itself. So yeah, all sorts of things are going to react to these earthquakes. One of the biggest things that we know from watching earthquakes around the world is do not try to run. So I know personally I have a lot of trouble just walking on solid ground sometimes. You can fall, but if the ground is moving side to side, it'd be like trying to walk at an ice rink or something, which, yeah, you don't want to try that. So the biggest dangers, the times most people get injured, are being struck by falling objects or flying objects, or you get thrown to the ground by trying to move during the shaking. So this is why when we say drop, cover, and hold on is the best safety action, because when you drop to the ground, you keep your center of gravity low. You are less likely to be thrown to the ground by the earthquake. You want to do it yourself, not unintentionally. So it's drop, get close to the ground if you can. Cover, you want to cover your head and neck. Those are important parts of your body. Your brain's pretty important. So you want to cover it with something sturdy or get under something sturdy. Take cover, like the students getting under the desk or you getting under a sturdy table. So these are very important. Drop to the ground, take cover, and then hold on. You want to hold on to your cover so it doesn't shake away from you when all that movement side to side is happening, and hold on for the entire time. So when I ask people about the Nisqually earthquake and how long it lasted, a lot of things I get are, it felt like it lasted a lifetime, 2 minutes, 3 minutes. It lasted about 30 to 40 seconds of shaking. So just think about, you got to hold on for that whole time, and it's going to be intense. And yeah, another thing to expect during an earthquake, you might be scared. The ground is moving beneath your feet. That is completely okay. Just drop, cover, and hold on and hold that position. Be aware of your surroundings. You can survive the earthquake if you get prepared now. So we're going to look at what this might look like, and again, an example of why not to run. Here's an example of an earthquake that happened in Ecuador in 2016 up in a building. So you get the people start moving as they start to feel it. You can see minimal shaking, and then the big side-to-side shakes come, and you can see people just being knocked off their feet out in the hall. So this is, again, that idea that you don't know exactly how strong it's going to be when you start to feel the shaking. So when you feel the ground start to shake, you want to drop, cover, and hold on immediately in an appropriate way for your situation. So in this case, that would be getting under these desks so that computer doesn't fall on you and so that you're in a safe place. Again, even up in a skyscraper. So here's another example, and we're talking that unreinforced masonry building. Watch this building on the right here as the side just completely peels off. This was during one of the aftershocks in the New Zealand earthquakes that happened in 2010, 2011. You've heard of the Christchurch earthquakes. So these had a lot of devastating aftershocks that happened, just more earthquakes that happened afterwards. So again, these people are outside, but if they were right next to the building, that would not be a safe place. You want to be away from these unreinforced masonry buildings, which is pretty much anything that looks brick that doesn't have any bolts into it. So yeah, these can be scary and extremely sudden. You saw how fast that went. All right, so I'm going to talk a little bit more about earthquake intensity again, which Megan brought up. We have an example here. This is what the Washington Geological Survey geology portal looks like. So you can pull up these earthquake scenarios Megan was talking about, and you can see from a certain fault. In this case, I have the Chelan fault, magnitude 7.2, which is a historical earthquake that happened in Washington. It's one of the largest back in 1872. This occurred, and while we didn't have seismometers to measure it, you can actually look at newspaper articles from that time to find out what was happening to people when they ran out of their cabins. There's interesting stories here, and you can actually read these historical stories, correlate them to exactly what type of shaking that was, how strong the ground was shaking, and estimate what the magnitude was. So based on these, they figured out it was about a magnitude 7.2. So when we look at these shaking intensities, again, an earthquake has one magnitude, the 7.2. It has all these different intensities depending on how far away you are from that fault and what type of soil you're standing on. Generally, softer soil like sand is going to shake stronger than hard rock. So you can also zoom in on this. And we're showing examples of what these different intensities might experience. And again, we have some of the cities. You can see Chelan right here. They're right in the middle of this severe shaking magnitude, Mercalli intensity 8, where it's cracking some of the walls here. Now, these are kind of just representations of a general house that has maybe drywall on the side that might be cracking, but these windows are almost gone in this case. Moving further away, you just get more things like falling off the shelf. Some people are going to be more sensitive and start practicing immediately. We want you to be these people who get under the table immediately when that earthquake starts, because you don't know what kind of intensity you're going to get right when it happens. Further away, you're getting a little less intense, but still knocking things over on the shelf. That's still strong shaking. And then even further away, you're still going to feel that there's an earthquake. So it really depends where you are, what kind of soil you're on. But if you start looking at these, you can get an estimate from this geology portal from Washington Geological Survey of what type of shaking you might expect in your area. Just look at all the scenarios for faults in your area if you want an idea. And remember that we don't know exactly where all the faults are. Sometimes you can't tell till they start shaking. But just know that we live in Washington and there's a reason we call it earthquake country. So here's an example of a shake map. Again, this is from the United States Geological Survey. This was the 2001 Nisqually earthquake. So you can see that all over the Puget Sound area, people experience strong and very strong shaking, maybe even a little bit severe in some of these river valleys where the sediment is a lot softer than some of these other areas. Again, this caused a lot of damage all over the area, shut down parts of Olympia. I'll show some of the side effects later. But if you felt this is a representation of what you felt based on where you are. Again, this earthquake only had one magnitude, 6.8, but all these different intensities depending on where you are at the time. So we can also look at where the unreinforced masonry buildings are in the state, so we can start understanding how to retrofit those. Take those walls that are not bolted to a floor and bolt them to the floor. It's expensive, but it's worth it when you start thinking about people walking by on the sidewalk. Immediately worth it. So when we start to, the Department of Commerce did an inventory of our buildings in the state to try to find where some of these are concentrated. So again, we got these red colors like in Seattle. That's where you get the most concentration. And then the Olympia area has a lot as well as close to Portland, just Clark County there, like Vancouver. So this is only for Washington, but you can see that there's other concentrations like Spokane has a lot of buildings as well. Again, it doesn't take as much shaking to start knocking the walls and parapets off. So these are dangerous in an earthquake, even a smaller one. Where this becomes really important is we start looking at the school buildings. So you can find this infographic at the website below. There's a link to it. This is a database on the Department of Commerce from the Department of Enterprise Services, but really they were just trying to do the first step in understanding where these buildings are. I'm just looking at buildings that were built before 1958 because that was kind of a time where we started to get building codes that were better. Again, in the US, a lot of people around the world have this feeling that when the ground starts shaking, you want to run out of a building. Our building codes are such that buildings are not very likely to collapse in an earthquake. Actually staying in them and under your desks, under something sturdy is better in the US. Not necessarily the case everywhere, but these are our building codes. They're meant to withstand that. But these unreinforced masonry buildings, when you start to run outside of them when the ground's shaking, you are right in the path of these parapets falling off the roof. So you don't want to be there. Okay. So when we start to look at those schools and how important that is, this is why when we have the great shakeout drill every year, coming up in a couple of weeks, Kiana will talk more about that. We've really emphasized that children in schools need to learn what to do to protect themselves during an earthquake. We have some students that just say, you get under your desk when the ground starts shaking. That is great. We want it to be drop, cover, and hold on so that they understand this is appropriate to other situations and not just desks. But something sturdy, drop, cover, and hold on is what we work on teaching. Now in 1949 and 1965, I believe it was, we had two other earthquakes that were very similar to Nisqually, deep intraplate earthquakes. A couple of those did result in children dying in schools that were on reinforced masonry because they ran outside the building and were struck by falling bricks. We need to reinforce these unreinforced masonry buildings, and we need to teach the children that it's safer to stay inside, the students. So that's why this is important. So another example of this, that Anchorage earthquake again. In Alaska, you can see how this works and how people that have practiced it a lot. This video, the school was just being recorded at the time. So right then, you can notice that the ground starts shaking and immediately all of these students and the teacher get under their desks. They start practicing what they're going to do. And that was just minimal waves, and then it starts shaking very strongly. And you see that everything's falling. You get a couple things falling on desks, books falling off of them. But the students are safe under their desks there. And there's those lights flickering and going out. Earthquakes might cause the power to go out. Another reason to be prepared, Kiana will talk about. So we want students to get under their desks and drop, cover, and hold on, but also understand what to do in different situations. Why go under your desk if the building's going to collapse? This photo from Mexico City, 1985 earthquake, even in these cases where this building is pancaking, which buildings are designed not to do in the US, it could save your life. These desks are holding up the building. If they were under those, that's a much better place to be than above them or trying to run out and down the stairs in these cases. So I think that's a pretty impactful picture. Okay, so some of the things you can expect during an earthquake and what some of those effects are. So I mentioned earlier how buildings are designed to stay upright to resist gravity. But when they start shaking side to side, you're going to get a little bit of a difference there, which is bad for these bridges, like in this picture. Now, these pictures all come from other countries, things that have happened in other parts of the world. But you can get items shifting off their foundations, which can happen if your house is now bolted to the foundation. Wood frame houses are very unlikely to actually collapse. They're the least likely of the structures. But they can shift off their foundations if they're not stuck to them, which can also make them a total loss. So side-to-side shaking is something to think about. Liquefaction as well. Now I bring this top left corner here. This photo is from the Nisqually earthquake in 2001. So how this liquefaction works, it's kind of like the ground turns to a quicksand of a sort. You might have experienced this if you've ever been to the beach. And there's a lot of water right underneath the sand, and you start to kind of shake your feet in the ground, and you notice you start to sink in. It's the same when you get this frequency of shaking. The water moves up through it, and the sand kind of loses its structural integrity, and things just kind of sink into it. So this example here is from Tumwater, and it was this lateral spreading where the sand kind of comes up and then just spreads apart. This can also cause a lot of landslides during earthquakes. That can also cause these sand blows, they're called, where sand just kind of comes out of the ground. And then in extreme cases, you actually get things sinking into the sand. Now you can look at DNR's geology portal and see which areas are most susceptible to liquefaction. Mostly it's river valleys where there's a lot of water under the sediment. And these are places where things shake extra hard during an earthquake. But also where this liquefaction can happen, which is bad for bridges, for roads. Another effect is fires. Famously, the 1906 earthquake in San Francisco, there was a fire afterwards because when you start to mix any sort of electricity, in this case, maybe it was knocking over open flame sources, you have to be careful with this. And we have electricity mixing with gas that might be damaged, gas lines. So Kiana's going to talk more about how to be prepared for that sort of thing. But sometimes after an earthquake, the fire can cause even more damage than the earthquake itself. So we have to make sure there are ways to make sure that the police and fire can get out and start stopping these from spreading after an earthquake. And also aftershocks. So Megan was talking about how the fault suddenly switches from elastic to brittle deformation. It slips. Now that's only that section along the crust, or along the fault itself. The rest of it is still waiting to deform a little. It's kind of like when you wake up, you might have your back crack once, but there might still be a few more in there as you adjust to waking up in the morning. A few more snaps coming off. Sometimes it can be a lot. So this is an example. Every single one of these dots, they're shown through time, is an aftershock from the earthquakes in the Christchurch area of New Zealand from 2010 to 2011. Now, there were over 10,000 aftershocks for this. Extremely intense aftershock sequence. And some of the ones that were very close to the surface were very damaging, especially the ones in Christchurch. So this happened over 6 to 7 months. This happened throughout the year. Now, we had the Ridgecrest sequence in California last year, where the aftershock happened on, well, the initial earthquake happened on July 6th, and then the aftershock was actually larger 2 days later, or a day later. And this is something that can happen. You don't know what's the aftershock and what is the main shock, or it's later called a foreshock until after the event happens. So they'll tell you that after, but USGS can create aftershock forecasts where they let you know what the odds are of certain size aftershocks happening. Okay, so what do we do in emergency management here? Kind of switching gears a little bit. We have to look at what might happen during our worst case scenario earthquakes. In our case, Cascadia subduction zone, like Megan was talking about. So we kind of have a traffic light pattern here with an extreme red light at the top. And these are going to be the colors used to look at what might happen in a Cascadia subduction zone earthquake to different types of infrastructure. So if we look at communications facilities, so we have a lot of red to the west on the Olympic Peninsula and the west coast, and it gets closer to green as you move inland, but there's still a lot in the Puget Sound lowland area, a lot of reds and orange. So where red is completely destroyed, these communication facilities are not usable, or they're going to take a lot of time to repair, to orange areas where they're going to take a lot of time to repair. So this is from a magnitude 9 earthquake in the Cascadia subduction zone. We need to know what might happen to our communications facilities, cell towers, things that will allow us to talk to one another afterwards, as well as TV stations. Now, when we talk about utilities, we're talking about gas, we're talking about these types of lines, electricity, petroleum processing, things like that. So again, this is mostly red as you go to the west, a lot more damage there closer to the fault. Again, as you're closer to the fault, you're going to get more intense shaking. And with that more intense shaking, more liquefaction. And then this earthquake is going to cause a tsunami as well, which is going to affect all 3,000 miles of coast. That includes all the islands, all the sound, all the harbors as well. So this is really intense damage that's going to happen along all our port facilities and their utilities. So think about that much damage happening from the one earthquake. And then transportation areas as well. So all these airports. Why this is important when we think about how we're going to get supplies out to the areas that need them after an earthquake. So again, most of the damage is red, complete damage to these facilities. Further west you go, but still a lot to these like ferry terminals and a lot of railways along the Puget lowlands. Again, it's mostly green as you move east, but you have to think about these passes. And if there's a lot of landslides caused by these earthquakes, how are we going to move things across the passes? Some other things that we need to consider, these facilities are schools. We've learned very quickly this year how important it is to have children in school to that recovery. If parents are not able to go to work and they need to stay home and watch the children, it is going to be difficult to get the economy recovered. Hospitals are very important. There's a lot of damage, especially in the West, to those, but a lot can still function. But some things we need to think about as well are the long-term care facilities, police, fire, emergency medical services. How do we get people to those hospitals? And then supply chains. How would you get the medical to those hospitals? Things like pharmacies. And then commuter routes. How does everybody get to work? You know, like a lot of people that live in Pierce County work in King County. What about all these roads and bridges along I-5? So these are things we need to think about so we can start working to mitigate them and the impacts they might have. So one of the tools that we can use to start mitigating this, kind of giving you a preview here of what's coming up in the next year. So USGS's Shake Alert, earthquake early warning system for the west coast of the United States. Now this is currently working in California, giving public alerts, There's a few cell phone apps, and Google is now delivering alerts on all Android phones. And it's also operating on a lot of automatic systems. Now, earthquake early warning is only part of the system of how we can start to mitigate these earthquakes. Again, you still need to retrofit your buildings because it's not going to prevent structural damage. And you still need to do things like close your cabinets with earthquake latches so that they don't open and all your plates don't fall out. But this is one tool that is really going to help people to immediately take that protective action to prevent injury from themselves. And there's some other things it can do as well. Okay, so what this does is it tells you that an earthquake has occurred. This is not a prediction for earthquakes, but it tells you this before the earthquake shaking reaches you. Again, you get that slip on the fault that here's the diagrams Megan was showing. We have the P waves, which move first. It's kind of like a sound wave. They move about twice as fast as the S waves or secondary waves as they move out when the earthquake occurs. So we have sensors all over the Pacific Northwest. The Pacific Northwest Seismic Network sets those up, part of the USGS. They can detect these fast waves, and you notice that that secondary wave is still way behind it. As that earthquake continues, when it's detected by a certain number of them, it calculates the size of the earthquake and approximately how far it's going to reach. So those areas where the earthquake is going to cause some shaking. Again, this wave is traveling much faster and before that heavy shaking arrives. So this is sent out to the servers and it's sent out to end users. And it can be sent to critical infrastructure, automatic users, but also to the people so they can drop, cover, and hold on before that damaging shaking arrives. Now, it's important to know that the people who are very close to this, they're going to get a lot less warning, possibly none. But in the studies of other areas where this works, like Japan, people are still grateful to know that when the ground starts shaking, they get an alert that says, hey, this is an earthquake. Because sometimes it's hard to tell initially. You get that fear reaction where you're not sure what it is. So it's nice to have reinforcement. So how will people use it? Most importantly, when people get this alert on their phones, they can drop, cover, and hold on, move away from those hazardous areas, seconds to tens of seconds of warning. They can also secure delicate procedures. We always put up this picture of somebody operating on an eye. Wouldn't you prefer if they had several seconds to tens of seconds to get out of the way a little bit before maybe take those scalpels and move them somewhere a little less delicate? Yeah, I'm sorry for the image. Also, this can be used for automatic systems. This is where you're going to end up saving lives as well as mitigate some of the damage to earthquakes or from earthquakes. So think about being in an elevator during an earthquake. Now this can automatically send a signal that returns them to the closest floor and opens those doors. You don't have to be trapped in an elevator, and that saves people from having to be rescued. Some other ways this is used: transit, trains. This is already used on the Bay Area Rapid Transit in San Francisco. Reducing the speed of those trains significantly reduces the risk of injury and damage to the train itself. So you can save your train, save people, and save money in this situation. In industrial sites, you really don't want these explosions, these fires to happen. And we have this working in Washington already, actually, at some of our water and wastewater facilities to prevent these disasters within a disaster. So what's the schedule for this? It's coming soon, public alerting to your phones. We're working on a cell phone app, 2 weeks ready, which will also integrate preparedness tips Kiana is going to talk about for not just earthquakes and tsunamis, but also a number of other issues we can have. We're still working on testing it to make sure this is going to arrive fast enough so you get those seconds to tens of seconds warning. And this should also be coming out via the Wireless Emergency Alert, or WEA, which is very similar to where you get Amber Alerts. So this is kind of a preview, but the schedule is this should be coming out in spring 2021 after we do a little bit more testing. But that's something to look forward to. So with that, I would like to switch back to Kiana presenting, who can talk a little bit more about how to get prepared for these types of events now that you know what to expect.
Okay, hello everyone. My name is Kiana Kabanji. I am the Disaster Preparedness Outreach Program Manager for Washington Emergency Management. And the fun little graphic you see on your screen here, this was created by a middle school student last year for our shakeout. youth video contest. We had a lot of fun, has so many great entries, and this is just one little clip of the middle school winner we thought you'd like to see. Okay, so today we are going to talk about preparedness. You have heard so much information about earthquakes and what can happen here in Washington. You've learned how they happen, what to expect when an earthquake does happen, and now you may be thinking, now what? I live here, I don't want to move, and I live in earthquake country, so what do I do? Now what? So we're going to answer that today. Let's talk very quickly about preparedness. And what is preparedness? Being prepared allows you to reduce the impact a disaster can have on you. So we can't predict all disasters, we certainly can't prevent them, but we can be prepared for them. Any actions you do to prepare you and your family will reduce the impact that a disaster could have on you. So let's go back to Vivox. So if you still have your phone, your tablet, or your other internet browser handy, you'll see there's a new question here for you. And if you are not signed into Vivox, don't worry at all. You will not miss out on anything. You'll still see all the answers right here. But if you happen to have it handy, go ahead and pull it out now. A question for you today. Were you prepared for a disaster before the COVID-19 pandemic started? There are 4 options here, and you may fit into one of these categories. You might feel like you don't. Don't worry, no grades for this. Just getting some feedback on how did you feel your level of preparedness was before the pandemic started. So did you feel completely prepared? You didn't visit a store for weeks. You were ready for that stay home order. No problem at all. You were totally prepared. Or were you mostly prepared? Maybe you had to run to the store just to get a few supplies, but for the most part, you had what you needed. You had planned ahead, you were prepared. Or were you that person who stood in line at the grocery store for an hour to buy toilet paper? You maybe were that person. There were a few of those folks around the state, around the country. Or are you maybe unsure that we are experiencing a disaster here in Washington today and around the country? I think everyone's aware that we are in a disaster, and we've even had other disasters on top of the pandemic. So I'll give it a few more seconds to see everyone's responses. How prepared did you feel before our big 2020 disaster of the COVID-19 pandemic? All right, we will close this poll. If you didn't have the chance to answer, don't worry, there's more questions coming up. And these are awesome results. You can see that almost everyone here today was mostly prepared before the pandemic started. That is fabulous. I am so proud. I'm so impressed. And I too feel like I fell into that category of being mostly prepared. I was ready to go. So now think about, you were prepared for the pandemic, but other hazards are around us that are unpredictable and could happen at any time. We call them no-notice events, like earthquakes. We could have all kinds of other hazards, so make sure you prepare now before the next disaster happens. Okay, so really quickly, let's talk about what preparedness is and what it is not. Preparedness is, maybe here's an example, every time you go to the store, you add just a few things to your cart, maybe 2 cans of beans and 1 extra bottle of hand sanitizer every time you go. And when you get home, you store these things all together in a go bag or in your 2 weeks ready kit, in your stockpile, whatever, but you're just slowly over time adding to your supplies that you have on hand. Preparedness is not what we saw in March and April of this year when people heard on the news that something was starting to happen and people flooded to the stores and grabbed everything they could see, whether they thought they needed it or not. That is not being prepared. So I strongly urge you, please prepare yourself, prepare your family, your household before the next disaster happens. Not all disasters are going to give us warning like the pandemic did. We won't have warning in all of our disasters. So make sure you prepare ahead of time. There are 3 simple steps to being prepared. You can do it. Everyone can do it. It's simple and easy. If you have kids, it can even be fun too. So these are the 3 steps you can see on your screen. You first need to know your hazards, to learn and know about what could happen around you where you live. The second step is to have a plan, meaning what are you going to do if? And filling in that sentence. The third step is building kits. So we're going to go through these steps today. While I'm talking, if you have any questions or comments for our previous awesome presenters, Megan or Brian, please feel free to add those in the Q&A box. We will have a question and answer time at the end of my presentation, so please, anytime, throw some questions in there. They'd love to answer them at the end. Okay, so let's talk about risk really quick. Both Megan and Brian mentioned this, so I'm going to fly right through this. I'm going to speed over it. This website listed on your screen is a phenomenal resource if you live here in Washington to learn about the risks and hazards around you. So I strongly encourage you, grab this website. It'll also be in the Q&A box, or you can use your phone to scan the QR code on your screen. When you go to this website, it'll look like this picture right here. Go ahead and click on that icon of Washington, like Megan mentioned, and this map will open up. Now, the neat feature that I love about this map is in the search bar at the top. You can type in any zip code, any city, any part of Washington. The map will zoom right to that area, and then you can use this menu of hazards to toggle on and off what you want to learn about. So this is a great tool to learn about what's around your home, or what your hazards are where you work, or even if you're going to travel, if you're going to go visit the beautiful Washington coast, I suggest you check this out first and find out what your evacuation route, or even print out or download your evacuation map. So this is a great tool. Please check it out and learn what hazards are around you. Other hazards we can have here in Washington are wildfires. We've all experienced that in the very recent future. We can have other human-caused hazards like civil unrest. We can also have other geological hazards like landslides, volcanoes. Trivia question, or rather fun fact today, we have 5 active volcanoes in Washington. So if you want to learn more about those, they're very interesting. You can check that out at our website. That's mil.wa.gov/volcano. Lots of great information there. So Washington can have many hazards, so make sure you are aware of what kind of hazards are around you that could cause a disaster. Okay, so we've talked a lot about earthquakes today. You have so much information about earthquakes, and Brian talked about what to expect. The one key thing that you can expect in an earthquake is that the normal things you rely on every day will be disrupted. You can count on that happening. Your normal transportation routes, the stores you would normally go to, your communication, anything you use in a day-to-day basis will be disrupted in an earthquake. So it's important to know what to expect so you can be prepared for that and have other options. So you have learned today, if you didn't know this before, the right thing to do when you feel the ground shaking is drop, cover, and hold on. Brian explained that and a few other scenarios. If you or a family member uses a cane, very similar situation. Remind them to drop, cover, and hold on. Similar situation for using both a walker and a wheelchair. You want to lock, cover, and hold on. So if someone in your circles of influence uses a device for mobility, make sure you teach them what to do if an earthquake happens. Now let's quickly talk about what to do after an earthquake. And this is not specific just to an earthquake, but any other no notice event that happens suddenly. It can be scary and people will be hurt. So you have 3 priorities after an immediate event like this. The first priority is yourself. You want to make sure you are okay, check if you're injured, if you need first aid. The next priority are the people around you. You want to check the people around you, make sure they're okay and that no one else is injured. And then your third priority is your environment, maybe the building you're in. If you're outside but you're by a building, you want to look and see where you are and determine if that's still a safe place to stay, because it might not be. And if it's not safe, when the ground stops shaking, make sure you move to a safer location. So that was step 1 of being prepared, learning about your hazards. The next step is to have a plan. Having a plan, like I said earlier, is asking yourself what if questions. What if I can't communicate with my child's school? What if I can't take my normal route to work or to home? What if I get a flat tire on my car? What if, and then start answering those questions for yourself. Having a plan will give you peace of mind that when something happens, it will be okay. Your family knows what to do, your household members, everyone knows what to do. You're all on the same page and you know how to reunite with them and communicate with them. Also think about plans for anywhere else you spend a lot of time. So you'll want to have your family plan, and that's relevant to you at home, or even if you're scattered around, you know what your family will do. But make sure you also learn about what's the plan for if there's a disaster when you're at work, or when you're at a community organization, or maybe a church. Wherever else you spend time, make sure you know what that organization's plan is for if a disaster happens. Another piece of your plan that's so important is having a communications plan with your family. We can expect that in an earthquake, the normal services we use for communication likely won't work. We may not be able to make phone calls, and even if we do, we need to save that for truly life-threatening emergencies and first responders. So, in a disaster, the best way to communicate with your family, your friends, your loved ones is to send a text message. But even then, if multiple people are trying to communicate with each other that are in the impact area, the communication services may be so overwhelmed that it won't go through and your messages won't be sent. So it's so important to have an out-of-area contact. And this person is a friend, a relative, somebody else that you know who lives out of the Pacific Northwest. They live somewhere else in the country or in the world. And when a disaster happens here in Washington, they will be just fine. They will have internet access, they'll have news reports, they'll have cell phone access. Their communications will still be up and running and normal. So that person can work as a relay between you and your family and your loved ones. So choose someone, make sure you tell them, hey, can you be my out-of-area contact? And then communicate with your family that when an earthquake or another disaster happens, we are not going to call each other. We're going to text Uncle Bob in Texas, who is our out-of-area contact, and then he can relay messages between everyone. So, question for you. Let's pull out your phones again, or your tablets, your internet browser. Question for you, where does your out-of-area contact person live? There's a few options here for you. I just chose some random answers for you. So is your out-of-area contact person on the East Coast? Are they in the Midwest? Or are they in California? Because that's where mine are, and I hear a lot of other folks who say their out-of-area contact person's in California. Or do you not have an out-of-area contact person, which I know you're going to have that fixed by tonight, so you don't have an out-of-area contact person yet. Or do they live somewhere else? So we'll give this a few more seconds, give everyone time to respond. Where does your out-of-area contact live? East Coast, Midwest, California, you don't have one yet, or somewhere else. And ideally, you want this person to be out of the Pacific Northwest. So not down in our neighboring state of Oregon, not just across the mountains over in Spokane, but out of the area. All right, let's see what the answers are. And quite a variety, wow. And California actually has the fewest responses, and that is okay because they have a lot of disasters too. So this is great. I'm so excited to see how many people do already have an out-of-area contact. And for the 19% of you who don't yet, please get on that tonight. It's really important. Okay, so there are lots of things you can do to help your home, your house be better prepared for a disaster. Brian mentioned a few things, and this can be fun. This is called a home hazard hunt. So grab your kids when they are driving you crazy and want to do something, and give them a piece of paper and a clipboard and walk around the house and identify things that could cause you to be injured or harmed in an earthquake or other disaster. So use earthquake as your scenario. That's typically our worst case scenario that we plan for here in Washington. So walk around your house, identify any heavy things that haven't been strapped to the wall, anything that could fall, maybe glass that's up high that's not strapped down. Maybe it's your bowling ball collection that you have mounted up above your bed. That's a bad idea. Let's find somewhere else for it. So make a list of hazards you find in your house, and then over time, one by one, start fixing those things. It can be really simple. It can be as simple as securing large items and mounting them or strapping them to a wall or to something else so that they don't fall and injure you or your family in an earthquake. A couple other things you can do at home to better prepare you and your family is one of them is to have a meeting location in case you need to get out of your house. So let's use a home fire as an example. If there's a fire in your home, you want to make sure everyone gets out safely. So let's choose somewhere immediately outside your house. Maybe it's a mailbox, maybe it's a tree, maybe it's your neighbor's door 5 houses down, whatever it is, just communicate and decide as a family where you'll meet if you need to get out of the house. Another really simple thing you can do, you could do this tonight, that would make you better prepared for a disaster, is to put a few supplies underneath your bed, underneath your kid's bed, any bed in the house. Have a few supplies. One of the greatest or the most number of injuries we see after an earthquake are cut feet, because especially if an earthquake happens at night, you'll be rolling out of bed after securing your head and neck with your pillow. You did your stay in bed, cover and hold on, the ground stops shaking, and then you want to go check on your family, but there might be broken glass all over the ground or other damaging items that could hurt you. So keep an old pair of tennis shoes, something that'll protect your feet, maybe a flashlight, some hard or heavy duty gloves. Keep a few supplies under your bed to give you more options to keep you and your family safe in an earthquake. And for utilities, not all homes or apartments use natural gas, but if you do, make sure you know how and when to turn it off. There are 3 reasons you would want to turn your natural gas off, and those are if you can smell it, it's going to smell like rotten eggs. If you smell that, you want to turn it off. If you hear a hissing sound like it's leaking from a pipe somewhere. Or the 3rd reason why is if you see the little dials spinning very, very fast. In any of those cases, there could be a natural gas leak, and that could cause fires, like Brian mentioned in San Francisco. We don't want to cause another disaster of fires while we're already dealing with an earthquake. So if you have utilities like natural gas, make sure you know how to turn it off. And also make sure you teach your family where the water shutoff valve is for your home. That'll be a valve clearly labeled in your home, not the one out in the street. Make sure everyone knows where that is and how to turn it off. Now, another critical piece of your plan is signing up for local emergency alerts. We can't let you know that something is happening or about to happen if we can't get a hold of you, if we can't alert you. So please, I strongly encourage everyone, grab this website right here. You can also use your phone to scan the QR code. This website, mil.wa.gov/alerts, will give you the list of all of the local emergency alerts in Washington. If you live outside of Washington, no problem. Just start doing some internet searching for your county's emergency alert system. This is so important. Once you sign up, I promise you will not be spammed. You will not receive random messages out of the blue. You will only receive an important alert in a message. It could be a voicemail or a text or an email when something is about to happen or immediately happening. And you'll get instructions on what to do, where to evacuate, or where to go. So please sign up for your local emergency alerts. And another way to stay informed and have information on what is happening is to follow our social media pages. Our communications team is amazing at always pushing out good, relevant preparedness information that you will want to know. So here are great resources to find more information about the hazards around you and how to be prepared for them. Now, the 3rd step is to build kits. And this is typically what people think of when they think of being prepared for disasters. People imagine a big stockpile of supplies. And yes, you do want to have supplies at home to take care of you and your family in a disaster. So your goal is to be 2 weeks ready. That means having 2 weeks of food and water, clothes, pet supplies, anything else you use on a day-to-day basis, you'll want to have at home in your 2-week ready kit. You'll also want to have smaller kits. So in each vehicle, throw a backpack in there with a few supplies. At work, at school, wherever else you spend time, make sure you have a small bag, your go bag, with a few supplies in it that'll help you get back home where you have your 2-week ready supply. So 2 weeks ready can seem like a lot. That is a lot of food, that's a lot of water, but don't let that overwhelm you. Take it one step at a time. Preparedness is a journey. It's not a checkbox. You don't do it once and you're done. So give yourself time to get up to your goal of being 2 weeks ready. So here are the differences of the kind of kits you want. You want to have your 2 weeks ready kit. That'll probably look like many bags, maybe some storage tubs, any mobility devices your family needs, copies of important documents, that kind of thing. And then you'll also want to have that smaller kit that's in your vehicle or by the front door, ready to go. If you only have a minute to get out of your house, everyone can grab their go bag and get out. You will want a go bag for each member of your household. That includes your pets. So make sure you have enough supplies for everyone, that if you need to leave quickly, you'll have the supplies you need. Don't forget your pets, they're part of the family too. Now, water can be tricky. Some of us have smaller homes with not a lot of storage space. Some of us don't live near a river or a lake, and so water access might be difficult. But I truly think having 2 weeks worth of water is easier than you think. So think about some hidden water sources in your home. That could be your hot water tank. That could be your toilet tank. That could be maybe a creek that runs behind your house. There are lots of options for finding water, but make sure you do have a safe way to drink it or use it, like a filter or purification tablets. Give yourself many options, but make sure you do store some water too. That way, in case the power goes out and you don't have water, you'll still want to make a cup of coffee in the morning. So make sure you give yourself lots of options. I mentioned just a few minutes ago about how preparedness is a journey. And so this graphic here illustrates this journey that we are all on together, myself included. Think of this like a train. Everyone's on board. We're all on this journey, but we are at different places in the journey. So maybe you are like the individual on the far left who this is the first time you've ever even thought about disaster preparedness. That's okay. You're here. You're already far past some others who have never thought about it. Or maybe you have about 3 days of supplies. You've done a little bit of planning or preparing. Or maybe you already have 2 weeks worth of supplies. You have copies of all your documents. Your whole family knows what you're doing, and you should be doing this presentation. Maybe you're that person. Wherever you are on this journey, the important thing to note is that no, you're not done. No one is ever done. You'll notice at the end, it's a continuing cycle of being prepared. Your disaster kits need to be restocked. Items need to be thrown out if they've expired, and new things need to go in. You need to review your hazards. Maybe there's a new earthquake fault or a fault line near your home that you didn't know about, and you need to review with your family what your plan is. So don't be discouraged if you don't feel like you're very prepared yet. That's okay. You're on this journey. Just keep making steady steps. One step forward, be better and better prepared every day. Last question for you here today. If you can pull out your phones or your other devices, very honest question for you. How prepared do you feel for an earthquake if it were to happen right now? You have 3 options: that you feel more prepared than you did yesterday, or maybe you feel like, I have some work I need to do. Or are you prepared? You're ready to go, and now you're just really hoping it doesn't happen. So those are 3 options for you. Go ahead and choose one. This will be our last question of the day. Thank you so much for joining, and while we're waiting for a few seconds for more people to answer, just another reminder that this webinar is being recorded. The link for it is in the Q&A box. It'll be uploaded to our YouTube channel very shortly after we're done today. So you can rewatch this, or you can share this link with family members or friends who may want to watch it also. All right, people are answering. How prepared do you feel right now? Yes, we hope it doesn't happen, but how prepared do you feel? All right, we're gonna go ahead and close that. And most people feeling like you have some work to do. That's okay. Start somewhere, pick a spot if it's your home hazard hunt or building towards being 2 weeks ready. Pick something and just keep chipping away at it. One product I'd like to let you know about is our new Prepare in a Year guide. This guide has 12 steps that'll walk you through being better prepared. You can find this guide and other resources to help you on your preparedness journey at mil.wa.gov/preparedness. That same website is where you'll find all the resources and links and recording for this webinar. It's all on that website there. That website is also in the Q&A box, so you can snag that before you leave. One final thing I want to make sure you know about is the Great Washington Shakeout. It's been mentioned in earlier presentations. It is the third Thursday of October each year. So this year it's on October 15 at 10:15. So join us and join millions of people around the world as we all practice how to drop, cover, and hold on. Don't forget to register for that and add your tally mark to show everyone that you practice and you know what to do. You can register at the link that you see on the screen, shakeout.org/Washington. Last year we had over 1 million participants, and we're going to increase it this year. So make sure you register and get your vote counted. So now I believe we have almost run out of time for questions, but I want to make sure you get your questions answered. So if you have added a question to the Q&A box and it did not get answered, please submit it to this email address, public.education@mil.wa.gov. That can also be put in the Q&A box. You can copy it. Feel free to send any questions to that email address. It'll be in the Q&A box. You can copy it, send any questions, comments. We'd love to answer them. Like I mentioned earlier, all of the webinar information and resources, they're all at this website listed on your screen, mil.wa.gov/preparedness. With that, thank you so much for joining us today. Have a wonderful rest of your day and stay safe.